Hey there! Thanks for stopping by. Let's dive into something amazing together. Welcome to Next Gen EduBuddies. Don't forget to hit those buttons below to stay connected. Like, comment, subscribe. Let's keep exploring together.
The rock cycle describes the continuous transformation of rocks from one type to another. This process occurs over vast geological timescales, spanning millions of years. Earth's internal forces, such as tectonic activity, drive the rock cycle. External forces, like weathering and erosion, also play a crucial role in reshaping the Earth's crust. Magma formation begins deep within the Earth's interior. Intense heat at these depths causes rocks to melt. This melting process transforms solid rock into molten magma. Magma is less dense than the surrounding solid rock. Due to its lower density, magma begins to rise. The rising magma moves towards the Earth's surface. Volcanic eruptions involve the expulsion of magma onto the Earth's surface. This expelled magma is known as lava. As lava cools, it undergoes a process of solidification. This solidification leads to the formation of extrusive igneous rocks. Extrusive rocks are formed from the rapid cooling of lava above ground. Molten lava flows across the Earth's surface, gradually losing heat to the environment. As the lava cools, it transitions from a liquid to a solid state, forming igneous rock. The rate at which lava cools significantly influences the size of crystals that develop within the rock. Rapid cooling leads to the formation of small crystals, or even a glassy texture if cooling is extremely fast. Slow cooling allows for the growth of larger, more visible crystals within the solidified lava. Intrusive igneous rocks form from magma that does not reach the Earth's surface. This magma cools slowly beneath the surface. Slow cooling allows for the formation of larger crystals within the rock. The resulting rocks are characterized by their coarse-grained texture due to these large crystals. Weathering and erosion are processes that break down rocks on the Earth's surface. Weathering involves the disintegration and decomposition of rocks in situ. Erosion is the subsequent removal and transportation of weathered material. Agents of weathering include wind, rain, and temperature fluctuations. These elements cause physical and chemical changes, leading to rock breakdown. Sediment transport is the process by which eroded rock fragments are moved from one location to another. These fragments, collectively known as sediment, vary in size, from microscopic particles to large boulders. Wind acts as a transport agent, carrying fine particles over considerable distances. Water, in the form of rivers, streams, and ocean currents, is a primary driver of sediment transport. Ice, specifically glaciers, can carry massive amounts of sediment as they slowly move. The final deposition location of sediment depends on the transport mechanism and environmental conditions. Rivers transport sediment from higher elevations to lower-lying areas. This sediment includes particles of rock, soil, and organic matter. As rivers flow, they carry this sediment downstream. Eventually, the river's energy decreases, causing sediment to settle out. This deposition commonly occurs in lakes, oceans, or other bodies of water. Sedimentary rock formation begins with the accumulation of sediment layers over time. The weight of upper layers compacts the sediment below. Dissolved minerals precipitate within the compacted sediment. These minerals act as cement, binding the sediment particles together to form solid rock. Sedimentary rocks are formed through the accumulation and cementation of sediment. These sediments are often transported by wind, water, or ice. Over time, layers of sediment build up, creating distinct strata. The weight of upper layers compacts the lower layers. Minerals precipitate from water solutions, binding the sediment particles together. These layers frequently contain fossils, providing a record of past life. Metamorphism is a geological process that alters rocks. This transformation occurs when rocks are subjected to extreme conditions. High heat is a primary driver of metamorphic change. Significant pressure also contributes to the process. These conditions are typically found deep within the Earth's crust. Metamorphism results in changes to the rock's mineral composition and texture. Foliation is a distinct layering or banding observed in metamorphic rocks. It arises from the alignment of minerals within the rock structure. This alignment is primarily caused by directed pressure during metamorphism. Directed pressure refers to stress that is not equal in all directions. Minerals orient themselves perpendicular to the direction of maximum stress. This process results in the characteristic foliated texture of metamorphic rocks. Metamorphic rocks are created through the transformation of existing rock types. This transformation occurs under extreme heat and pressure. The specific conditions determine the type of metamorphic rock formed. The slate is one example of a metamorphic rock. Gneiss and marble are also examples of metamorphic rocks formed under different conditions. Tectonic plates converge, resulting in one plate subducting beneath another. The subducted plate descends into the Earth's mantle due to density differences. As the plate sinks deeper, increased temperature and pressure cause it to melt. The melting process generates magma, which can then rise to the surface. Geological uplift is a process where Earth's crust is raised. This uplift brings rocks from deep within the Earth to the surface. Exposure to the surface subjects these rocks to weathering. Erosion further breaks down the rocks, transporting the material away. This cycle of uplift, exposure, and erosion restarts the rock cycle. The rock cycle is a fundamental concept for understanding Earth's history. It provides geologists with valuable insights into past environments. The rock cycle reveals records of tectonic activity preserved in rocks. It also offers clues about past climate changes that have occurred on Earth. By studying rocks, geologists can reconstruct events in Earth's history.
Don't forget to click subscribe and join the family. There's so much more coming your way. Subscribe now and never miss out on the fun.